this video we're talking about the chain rule of differentiation. Basically, it's how to differentiate composite functions. And what I mean by composite functions is you have a function inside of another function like this, f of g of x. An example of this would be the square root of x squared plus 1. So in this case, your f of x is the square root of x, and your g of x is equal to x squared plus 1. And then when we put g of x into f of x, it's essentially this, f of x squared plus 1, which becomes square root of x squared plus 1, and that's a composite function. Now, the proof to the chain rule of differentiation is not the easiest proof to understand, but at the end of the day, the chain rule comes out to be this: dy dx is equal to dy du times du dx. And a way you can remember this is, say, these du's cancel and it becomes dy dx. That's not necessarily 100% accurate because they don't really cancel, it's just a notation. Yeah, the notation's set up to help you remember. Pretty ingenious, actually. But what does this mean? So it's basically, if you have a composite function, let's say x squared plus 1 to the 1/2. Same one we had last time, it's written a little differently. Basically, you make a u substitution. You say that u is equal to x squared plus 1. So now, from that, you just make a substitution, and this turns into u to the 1/2. So now it's a function of u now, but this is still, well, this was y equals, so this is still y equals u to the 1/2. So now we just follow this formula. This formula right here, which is first we find dy du. Well, that's just simply the derivative of y with respect to u. So that's 1/2 u to the 1/2 minus 1, which is 1/2 u to the negative 1/2. Then we find du dx, and du dx, it's a derivative of u with respect to x. So u is right here. The derivative of x squared plus 1 is just 2x. So now all we do is follow this, and it becomes dy du. Let me just dy du is u to the 1/2 times du dx, which is 2x. But we want it in terms of x, so we just make the substitution of replacing u with x squared plus 1, and we immediately get this. This is yes, I made it. I copied y, not dy. So yeah, I copied this, which is y. I should have put this in. So that becomes 1/2, and this is 1/2 negative. And then you could simplify, and this just becomes, when you simplify, it becomes x over the square root of x squared plus 1, and that's it. So basically, follow this formula. You put y in terms of u, find the derivative of y with respect to u, which is this. Find the derivative of u with respect to x, which is this. You look at a u function, multiply them together, and you got the derivative. Now, one thing that might be difficult for newcomers is, what do you replace for u? And when you do a few problems, it's fairly obvious what you do. But another way to teach this is to say, basically, if we have this one again, we take the derivative of the outside function, which is this whole thing. So if we take the derivative of the outside function, it's going to be 1/2 x squared plus 1 to the negative 1/2. That's the outside. That's treating this whole thing as one variable. Then take the derivative of the inside. So whatever's inside the parentheses, you take the derivative of that and multiply it, which is going to be 2x. So it's really the same thing, except it's doing it in your head instead of doing it explicitly like this was. So I think for demonstrational purposes, this way is better to show what's actually going on. But in terms of like doing it in your head, this is what happens in your head. This is what will happen in your head when you do enough problems to get good at it. So let's do a few more. So if we have the sine of 2x, y equals the sine of 2x. We make our u substitution. We're going to make u equal 2x, and then we're going now we have to find dy du. Well, let's write y in terms of u. This is going to be sine, oops, not sun, sine of u, right? Because u is 2x. So dy du is just cosine of u, and du dx is just 2 because the derivative of 2x is 2. So now you follow this formula, you multiply it together, and you get 2 cosine of u, but u is 2x, and that's your derivative. dy dx equals. There we go. Not too bad at all. It's basically the same thing. We'll do another one. Let's try x to the, let's see, how about 3, let's make it interesting, 3/4 plus 7 to the, let's just make it squared. So that's our function, y equals. So we do the same thing. We say u is equal to x to the 3/4 plus 7. So therefore, y is equal to u squared, because we just replace it with u. And then we find our d. I say a lot. I should stop that. So we find, not dx. We find our dy du. Derivative of y with respect to u is just going to be 2u. Derivative of u with respect to x is just going to be the derivative of this. With respect to x, that's going to be 3/4 x to the, let's see, 3/4 minus 4/4, that's negative 1/4, and then 7 goes away. So now we take these two, we multiply them together, and that gives us our derivative. Dy dx equals dy du, which is 2u, but remember that u is x to the 3/4 plus 7, so we'll just replace that, and then multiply it by du dx, which is this. We could simplify this a little bit. This is gonna cancel, make that a 2. This x is gonna get kicked down to the denominator. X to the, just write it like this, 1/4, and that's your derivative right there. So that's basically it. Let's see here. Yeah, that's basically it. Basically, all chain rules work that way. You just find a substitution for u. You find dy du, then du dx. You multiply them together, and that's it. So, good luck. Thanks for watching.